we have one last theorem that we want to prove about perpendicular lines. And this one has a name as well, and what it's called is the lines, and maybe I should actually put this higher, lines perpendicular to a transversal, theorem. Okay, so again, aptly named because I'm going to have two lines that are perpendicular to a transversal, and we're going to end up trying to say that they are parallel to each other. So in theorem form, what that is that says that if two lines are perpendicular to the same line, then they are parallel to each other. Okay, so this actually has one big caveat that's important to mention. One of the assumptions that we're making for a lot of these proofs that we're doing is that everything is in the same plane, and it's actually really important to be noted here. So what I really should say is if two lines that are in the same plane are perpendicular to the same line, then they are parallel. And the reason for that is what I could have happen is two lines are perpendicular to the same line, but if they do not lie in the same plane, then they will not intersect. They will instead be skew. And so maybe a better theorem would be that if two lines are perpendicular to the same line, then they just do not intersect. But that would be harder for us to prove because that would be in 3 dimensions, and we just want to focus on the 2. So what really should be stated here, though, is the fact that we're talking about in the same plane. So let's go ahead and make our diagram then. So I'm going to have two lines that appear to be parallel to each other, but we don't know what they are. And then I will have my transversal here. And this transversal is perpendicular to both of these lines. Perfect. All right, so I will write my givens then. So my givens in this case, so if two lines are perpendicular to the same line, so I really just need two statements about line T, my transversal, being perpendicular to both P and Q. So I will do that. That'll be no big deal. T is perpendicular to P, and T is perpendicular to Q. And what I'm trying to prove then is that P is parallel to Q. Then they are parallel to each other. Okay, so this one actually ended up being not too bad. And we can actually make it a lot easier if we just remember one of our theorems along the way. But we'll talk about that when we get there. So, statement 1 will be that T is perpendicular to P, and statement 2 will be that T is perpendicular to Q. That is given to me, and so is that. Okay, so now let's put a little bit of thought into this. So I know that as of right now, the only thing that I have to prove lines parallel to each other is to use, corresponding or alternate interior, alternate exterior, consecutive interior angles. And so I'm obviously going to have to use one of those. What I'm going to be able to do is, I need to maybe label some angles, is talk about 1 and 2 since they're corresponding angles. If they're congruent to each other, then these lines will be parallel. And so what I have to be able to do is somehow show that these are congruent, and because my transversal is perpendicular to both these lines, that means that these will be right angles, and thus they'll be congruent to each other. Okay, so let's go ahead and do that. So I need to talk about right angles. That's number 1. So statement number 3 will be that angle 1 is right. Okay. How do I know that? Well, it's a definition of perpendicular. Two lines are perpendicular if and only if they form a right angle. Okay, where did that come from? So angle 1 is T and P, so statement 1. And I'm going to do the exact same thing for angle 2. Angle 2 is right. Two lines are perpendicular If and only if they form a right angle. You know, you'd think I'd be able to use like some type of cut and paste or something. If only I knew how. Comes from 2. Okay. So, the common thing to do here is to forget about the theorems that we've done in the past and go through the whole, rigmarole of saying that, measure of angle 1 is 90 degrees, measure of angle 2 is 90 degrees, thus their measures are equal, so then they're congruent. Or I can use one of my theorems I proved before. I mean, that was the whole point of me doing that. And so what do I know about two right angles? I know that two right angles will be congruent to each other. That is my right angle congruence theorem, coming back to help us out. So, angle 1 is congruent to angle 2. My reason for that is that if two angles are right, then they are congruent. And that's coming all the way back from, well, several theorems, several videos ago. Then they are congruent. I will link together 3 and 4, saving us a whole bunch of steps. Because now I'm basically done. Angle 1 and angle 2 are congruent to each other. They're also corresponding angles, I can tell from my diagram. Thus, P will have to be parallel to Q. P is parallel to Q. How do I know that? Well, if the corresponding angles are congruent, then the lines are parallel. And the lines are parallel. Awesome. That comes from 5. All right, so this was actually a pretty quick proof here. Again, because I used my theorem. But all I was really saying was that, hey, if I have two lines that are perpendicular to the same line, well, they both have to form right angles. Thus, their corresponding angles will be congruent to each other, and these lines have to be parallel. So this is a useful theorem that we've just proven here, that if two lines are perpendicular to the same line, then they are parallel, that now we can use in any future proofs that we want to.